With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Question. Two identical uniform rods tied together with the help of a string are balanced as shown in the figure. So in this figure, two uniform rods are given and they are identical rod. Okay. And there is a string. With the help of this string, these two uniform rods are balanced and also tied up. Clear? These two uniform rods also are at 37-degree angle with the horizontal axis. So now what we have to do, we have to first find it out, the coefficient of friction. Okay, the coefficient of friction at this contact we have to find out. That means the coefficient of friction of the surface, horizontal surface. Okay, and along with we also have to find out the tension of the string, that is the tensional force. There are four options which are given. In these four options, it is mentioned that we have to find out the coefficient of friction. We have to find out the coefficient of friction in the when the system is equilibrium. If the system is in equilibrium, then what will be the coefficient of friction? Okay, and along with the tension of the string, that is the tensional force. So before that, first we will draw the diagram accordingly. So we have drawn here a uniform rod which is of length L, okay, which is inclined at an angle 37-degree with this horizontal surface. What we have to find out? We have to find out the coefficient of friction at this contact. Clear? Okay, so L is the total length of this uniform rod. Now we know that the center of the mass for a uniform rod is placed at the center, that is at the midpoint always, because it will maintain the symmetry. Symmetry means this half will be of length L by 2 and this half will be of length L by 2, and it will be the center of mass or the center or the midpoint of this rod. Okay. So at position O, we can say, because of the center of mass is placed over here, the total mass of the whole system, the total mass of this uniform rod is centralized at this point. Okay, so we can consider the total mass is at O. So there will be a weight and the direction of the weight is always vertically downward direction. So first we will draw the direction of this weight, which is vertically downward direction, mg. Okay. Next, this will be the direction of the tensional force because this is attached along with the help of a string, and we know that there is the tensional force of the string. Okay, so the tension will work along this side and the frictional force will work along this side, that is the frictional force. Frictional force always opposes the relative motion, so it will work along opposite direction of the tensional force like this. Okay, according to the diagram we can see this, and we also know that the frictional force is equal to mu into normal reaction force from the definition of frictional force. So what will be the direction of the normal force? The normal force will be directed vertically upward direction, that is exerted by this horizontal surface. Okay, so this will be the direction of the normal reaction force in. Clear? Now there are also two another forces which we have to draw. So what will be the formula which we have to apply in this equation, in this numerical particularly? We have to make the resultant torque 0 about this point. Okay, so suppose this is point P, we will consider it at point P. Okay, and this point P is in contact with the horizontal surface. Okay, so at this point we will find out the resultant torque, that acts about this point P, okay, due to this uniform rod. So there will be two torque. One torque will be due to the weight of the uniform rod and due to the tensional force of the string. Okay, so this is point P. About this point we are finding out the torque. So what is torque? As we know that torque is equal to the force into the perpendicular distance. Okay, the perpendicular distance. Okay, so now the first torque will be due to this weight mg. So now mg is directed vertically downward direction. Okay, so due to this mg, due to this force, what will be the perpendicular distance? We can see it clearly. The perpendicular distance will be along this direction. If this is mg, the direction of mg is vertically downward, then the perpendicular distance will be along this direction. So what will be the perpendicular distance? This component of this length. Okay, this is symmetry, so L by 2, and this half will be L by 2. Okay, this is angle of 37 degree, so this angle will also become 37 degree, interior alternate angle. Okay, this angle is also 37 degree, this angle is also 37 degree. So if this is 37 degree, then what will be the component of this length? It will be L by 2. Okay, because at this point we have to take only the half of the length at center of mass, so it will be L by 2 cos 37 degree. Okay, so due to the force mg, weight L by 2 cos 37 degree is the perpendicular distance, and another force is also present there, that is the tensional force. The direction of the tensional force is along horizontal axis, along this direction. So what will be its perpendicular distance? Its perpendicular distance will be vertically downward. This will be the perpendicular distance due to this tensional force. Okay, so now we have to take this vertical component of length. So what will be the vertical component of this length at this point due to the tensional force? Okay, so for the tensional force we have to take the whole length of the uniform rod, because at this point we have to include the total length of the uniform rod. Okay, so now what will be the component of the length for tensional force? It will be L sine 37 degree. Okay, understood? If this is the horizontal component, that is L by 2 cos 37 degree, then the vertical component will be L sine 37 degree. Clear? As because of this is also 37 degree angle, which I have already shown in the first diagram. So if this is L by 2, then it will be L sine 37 component. Okay, then what will be the resultant torque? The resultant torque will be tensional force, and the perpendicular distance is L sine 37 degree. Okay, then equal to, at equilibrium, it should be equal to the another torque mg into L by 2 cos 37 degree. Okay, so now L will be cancelled out. Cos by sine, so T into L sine 37 equal to mg into L by 2 cos 37. L and L will cancel out. Then 2 into T by mg is equal to cos by sine cot 37. Okay, and cot 37 value is 4 by 3. So again 2 and 4 will cut. So we will get T equal to 2 mg by 3. So this is the tensional force of the string. Now we will find out the coefficient of friction. Okay, so how to get the coefficient of friction? As we know that frictional force is equal to mu n. Okay, where n is the normal reaction force and n will be balanced with the vertical component mg, because there is no other components, that's why n will be equal to mg. Clear? So mu is equal to the frictional force mg. Now at equilibrium this frictional force must be equal to the tensional force, so T by mg as because of in the diagram it is clearly seen that there are no other forces that can balance the tensional force. Only the frictional force and tensional force, they are oppositely directed to each other, so they will balance also. Okay, so T value is already 2 mg by 3, we got it into 1 by mg. So mg cancel out. Okay, it will be approx 0.66 approx. Okay, so the value of mu is 0.66. Now we will verify all the options. So in the first option it is written coefficient of friction 0.8, tension is 4 mg by 3. Now we have to keep that in mind that maybe the coefficient of friction can increase, but the tension of the spring will remain same, will remain fixed. So this option is not correct. Again in option 2 the tension is given 2 mg by 5. This is also not correct. Option 3 is 2 mg by 3. So 2 mg by 3 will only be the tensional force and coefficient of friction will 0.9. It can be greater than 0.6. Okay, and option 4 is also not correct as because of in option 4 it is written 9 mg by 10. So this is not correct. Okay, thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.